Hey guys, I'm going to go over some more power with resistors, voltage differences, current differences, and I'll explain how straightforward it is and what it means. So with that said, I've written out what power is. Like we've described before, it's V squared over R, I squared R, V times I simply. And why, or what are you doing? Like what voltages do you pick? What currents do you pick? How do you know what node to go from? So basically I made this to show you guys and give you guys a little bit of a something to grasp onto to understand how it works. So let's start with the V squared over R. What does that mean? So in our last problem we had current going in here, current 1, and we had a current going out, which was I2, and we had a current going down, which was I3. Or simply we had something that looks like this as a circuit. And there was a -3 here, and I believe there was a +5 voltage here, and then there was a ground here. Now with that said, we had something called VA here, which we found to be 2 volts. So basically the way we did the equations, we were saying, okay, well VA minus 5 volts over your R1 resistor plus VA minus your -3 volts over your R2 resistor and so forth. So basically what that means is when you are setting a number like VA minus 5 is that you're saying that the current is going to flow from VA to the 5 volt source, or it's going to flow from VA to the -3 volt source. Or an example, if we did VA minus 0 over R3, which would be the last one, we're saying that VA, the current is going to flow from VA to ground, and it's going to go this way, I3. So if we get a negative sign when we're doing our equations for current, and we find, like, for example, in this situation, we had a negative number end up for current 1. So basically we chose current 1 to go in this direction, and what that simply means is current 1, it was really flowing in this direction. So what you want to do with power, it's the same exact concept. If you're thinking of a current that's flowing through some resistor and it goes in that direction, then what you would want to do is say, alright, power is actually the difference in voltages here. So you got V1 minus V2. So you're saying that your power flowing into resistor R is going to go in that direction from V1 to V2. If you come up with a negative number in power or a positive number in power, that just means that you're either supplying or demanding, meaning that you're either supplying power or you are simply getting power or gaining power. So another way to think of it would be like a power company. They create power for consumers. Consumers demand power, so they take it. And the generators are the utility companies. They're the ones that source the power. They're the ones that generate the power. So one's either going in or one's going out, meaning it's either being supplied or demand. It's either supply or demand. And if you get minus power, that means that you're actually generating power. So it'd be like if you had some sort of, let's say like a turbine or a hydro turbine, or even something as easy as absorbing energy from the sun, and you have something like a solar cell that will absorb that energy, and you can charge a battery. So if you're charging a battery, absorbing it, you're actually generating power. So you're going to have like a negative power. The number for power would be negative. If you are taking power, you're like a household, or you're using your cell phone, you're absorbing your battery's power at that point, and your phone will eventually die. So the source is your battery. Your electronics or whatever hardware is in there is what's actually demanding the power and absorbing that power. So in this case, if you get something that's plus in power, you're absorbing the power, you're using the power, you're demanding the power. If you come up with a negative power, that means that your source, you're generating power somehow. And it could be through, like I said, solar cells, You got water turbines, wind turbines. There's all sorts of generators that can do the same. So with that being said, we can move on to the second one. Well, what is I squared R? Well, it just depends what current you're choosing. So say we're choosing our current 3 in this instance up here. So we'd want current 3. Alright, well, what does current 3 equal? In the case of this situation, you got whatever's coming in, which would be I1, has to be equal to whatever is coming out, which is I2 and I3. So I2 plus I3 is I1. So with this relationship, we can say that I1 minus I2 is I3. So if we're looking through the current through there and you don't know exactly what it is, maybe you just solve for current 1 and 2 only, you can say this is current 3, and you can square it and multiply it by R. So this is actually the way in the last problem that the currents were flowing, which means that if we plug in what currents we got, we should be able to get the right answer. Now the third one is just your voltage times your current. This is a general relationship. Later on, I believe this comes with a sine of some sort of theta. Excuse me, it's cosine. And that could be your power factor, which has to do more with AC power and not DC power. But simply put, since there's no frequency, and you got cosine of 0, which would be your angle, you'd actually get voltage times current. And that's how that works. So in this case, you can do, again, it would be the voltage difference between whichever way you think your current is going, multiplied by whatever current you have. And again, that could be substituted I2 is equal to I1 minus I3. So let's try this out. Does this work? So basically, let's think about our last problem. We had a 2 ohms. I think we had 2 volts at this point. We had a 4 ohm. We had a minus 3 volts at this point. We had a plus 5 volts on this side. And then we had 8 ohms and a ground. So we can say, alright, well, what was I1? And we said I1 was going in this direction, so we can say it's 3, which is 5 minus 2, the voltage difference, which is 3 over 2. So basically our current was 3 halves at this point, so you can say, okay, that's 3 halves. And then you got minus I3, so in our case I3 is going down. We had 2 volts minus 0 volts over 8 volts, which is not plus, which is equal to a quarter. So basically we got a quarter, or we can say instead of a quarter we got, no, let's say 1/4, and then I'll switch out the 3, which is 6/4 is the same as 3/4, so we'd say 6/4. And we get something like 5/4 here. That comes from here. Alright, and then the second one would be V1 minus V2, which we're going through I2 right now. So current 2 went from VA minus 3, so it'd be V1 is 2 volts, and then we got minus is plus 3, and that's equal to 5. So then you got something like 5 times 5 over 4, which is equal to 25/4. Which, if you look at our last video, that's exactly what we got, is 25 over 4. Now, if you want to do I1 minus I2 times R to get the current for the 3, that's fine. Or the last one would be like V1 minus V2 squared over R, which is how we got this last one, V1 minus V2 over R. So in the last video, we took this equation to get 25/4. So we had 2 minus 0 over 4. Where are we at? The 4 ohm resistor? No, the 8 ohm resistor. So, with that being said, (25/4). Oh, this came from I2. That's why. Okay, so with I2, you have something like voltage 1 minus voltage 2, which was 2 minus negative 3 over, and that's squared, which is 5 squared, over your resistance, which was 4 ohms. So 25 fourths again. Alright everyone, I want to thank you for watching this video, and I will talk to you later.